In this review, we are going to talk about how to find the solutions to higher degree equations. And so you're going to do all the problems that I don't do for homework. And I am going to do with you 2, 4, 6, 12, and 14. So let's go ahead and get started with 2. Now, if you recall, make this a little bit bigger. Okay. If you recall, you can determine the number of solutions that you're going to have by looking at the highest degree term. And you generally want to have your equations in highest degree to lowest degree, and we want 0 on one side. So if you don't have that situation, which none of these are in that situation on this paper, but if you didn't have that situation, you would want to move everything to the side where your highest degree term would be positive. So let's look at number 2. So because our highest degree term here is x to the third, I know I'm going to have 3 solutions. Some of those solutions could be the same. Some of those solutions could be different. Some could be rational. They could be irrational. They could be real. They could be imaginary. So we'll talk about all that. All right, so I am going to have you factor by grouping. So anytime you have 4 or more terms, our first shot is to factor by grouping. Not all higher degree equations could you factor by grouping. So if that's the case, then, and all of these you should be able to factor all of these on this page. In class, once we get further along in class, we'll teach you how do you find the solutions if you can't factor by grouping. So from Algebra 2, you might remember synthetic division. You might remember how to find all your possible rational solutions by doing P over Q. And then we're going to talk about some different rules to help you narrow those choices down. But for right now, to factor by grouping, you're going to split your equation into 2 equal pieces. You'll have 2 and 2. And we're going to find the GCF of this group and the GCF of this group. Your GCF should be different in each of these 2 groups, but what's left in parentheses should be the same. So for instance, your GCF in this first group between x cubed and negative 2x squared is in x squared. So both terms at most have an x squared in common. So I'm going to factor an x squared out in front, and then we're going to find out what's left. So when dividing like bases, you subtract exponents. So 3 minus 2 is 1. So we get x to the first power. And here, negative 2 divided by 1 is negative 2. And x squared divided by x squared, they cancel each other out. So we are just left with an x minus 2. And if you remultiply, you ought to be able to check and make sure that you get what you started with, which we do. So over here on this section, when we factor out the GCF, what's left over in the parentheses on this section should also be x minus 2. If these are not the same, then either you did something wrong or it's not possible to factor by grouping. And in addition to that, anytime your third term here is negative, 100% of the time you're going to pull out a negative as your GCF, because we need the first term in each of these groups to be positive. So between 20 and 40, they both have a 20 that we can divide them by. But instead of dividing by 20, we're going to divide by a negative 20 because we want to make this term there positive. And so this is going to be divided by a negative 20, and I'm going to pull a negative 20 out in front. If your GCF is positive, then you would put a plus here. So please, whatever you do, don't just, if this were a positive 20, that you just put a 20 there, because then it looks like it's all multiplication. So these are going to cancel, and you're left with an x. And then 40 divided by negative 20 is going to give you a negative 2. So as you can see, what's in parentheses is identical. So essentially we're going to do a... Sorry about that. So essentially we're going to do a second greatest common factor. We are going, this is a factor and this is a factor because they are being multiplied. Negative 20 is a factor and this is a factor because they're being multiplied. So this term and this term have an x minus 2 in common. Why? because can't I divide this by an x minus 2 and divide this by an x minus 2? So just like we did up here, when we divide by the GCF, it comes out in front. So we're going to take that GCF of x minus 2 and pull it out in front. So for this one, these two are going to cancel. And we're left with an x squared. So the x squared is going to go here. And on the second one, these two are going to cancel. And we are left with a minus 20. So the minus 20 goes in here. So if we have something times something that equals 0, so a product equaling 0, either this one or this has to have a value of 0 for the product to be 0. So we're going to set x minus 2 equal to 0 and x squared minus 20 equal to 0 and solve. So to solve for the first one, we're going to add 2. So we get x equals 2, and boom, there's one of our solutions. For the second one, we're going to add 20, but we have x squared equals 20. That means I should have two solutions if I have an x squared. So remember, to solve for x, I have to take the square root of both sides. When I take the square root of this side, don't forget to do a plus or minus. So I'm going to take the square root of this side and plus or minus the square root of 20. So I get x equals plus or minus, and I'm going to prime factor 20. 20 prime factored is 2 times 2 times 5. So I get a pair of 2's that can come out in front. So my other two solutions would be positive or negative 2 radical 5. So in total, I have 1, 2, 3 solutions, which matches the 3 solutions I thought I should have. All right, so let's try that again, but let's look at number 4. Number 4 is a little different. This time you don't have 4 terms, you just have 3. And you have an x to the 4th term, you're missing your x cubed, and you have an x squared, you're missing your x term, and then you have a constant. So anytime you have a trinomial but with an x to the 4th, it actually factors just like a quadratic. There are factors of 48 that will add to give you 14. Even if they didn't, I actually could use the quadratic formula on this, but you're going to see that you have to do an extra step at the end. So for our purposes, we are going to look at that middle term. So whatever your middle term variable string is, you are going to let u, and we like to use u in pre-calc for a lot of stuff, we're going to let u equal x squared. So if u is equal to x squared, then what would u squared be? So if I square this, I'd have to square this. Well, x squared squared, power to power multiply, you would end up with x to the 4th. That gives me x squared here, that's going to be a u, x to the 4th here, that's going to be u squared. So in theory, I'm deciding to replace x squared with a u and replace x to the 4th with a u squared. Why? So that in your brain it's easier to factor. You've got u squared minus 14u plus 48 is equal to 0. At the end, we're going to have to go back and replace our u's with what they equal, which will be x squared. So we can factor this quadratic. As I said, if you read it backwards, the factors of 48 that add to give you 14 are. Well, let's figure them out. So our 48 is positive, so we're adding those factors, and we're looking for a negative 14. All right, so 1 and 48 add to give me 49. 2 and 24 add to give me 26. 3 and 16 add to give me 19. 4 and 12 add to give me 16. We're getting closer. 5 doesn't go into 48, but 6 goes in there 8 times, and 6 times 8 is indeed 6 plus 8 is indeed 14. We want our 14 to be negative, so the bigger of the two carries that sign, And then the 6 is also going to have to be negative to combine with that negative 8 to make a negative 14. U squared is going to become U and U, and then we're going to put the minus 6 and minus 8. So this is why your factoring skills are important. If you have a product that equals 0, then one or both of these should also equal 0. So we're going to set each of those factors equal to 0 and solve. If I add 6, I get U equals 6. And if I add 8, I get U equals 8. But remember that U is equal to x squared. So we are going to replace each of these U's with an x squared. So x squared is actually equal to 6. And x squared is actually equal to 8. So to solve for that x squared, you have to take the square root, plus or minus the square root, plus or minus the square root. All right, so square root of x squared is x. There is no perfect square in 6, so it's just going to remain plus or minus the square root of 6. So there are 2 solutions there out of our 4 that we're going to need because we have x to the 4th. And the square root of x squared is x equals plus or minus 8 prime factored is 3 2's. So that means I can pull a 2 out in front. So I get x is equal to plus or minus 2 radical 2. And there are your other 2 solutions. So we have 4 irrational solutions, which just means that they are decimals that never end or repeat. All right, so let's look at number 6. So for number 6, because you have 4 terms, it is going to be factored by grouping is what we're going to try first. So I'm going to group the first 2 with the second 2. I'm going to split it right down the middle, and I'm going to look for the greatest common factor. And if you can find the greatest common factor overall before you split these into 2 groups, you should do that first. 3 and 2 are both prime, so I know that I'm not going to have a greatest common factor for all 4 terms, so that's why I didn't even do that one first. But here, I don't have a greatest common factor with the numbers, but I do with my variables. And for the first grouping, you're always going to have a GCF with variables. It just always will be. So the most 2's I can take away from each one of these and take the same amount would be 2 2's. So I'm going to divide by x squared. And we're going to pull that x squared out in front. And so then 3 divided by 1 is 3. And then x cubed divided by x squared, subtract exponents, you get x to the first. And then plus 2 divided by 1 is 2, so plus 2. And then the x squared should cancel, so these just cancel. Then look at your next one. So here, 108 is rather large, and so is 72. So oftentimes, since I know I'm looking for 3x plus 2 to be over here, I'm going to take the 108 and divide it by 3 on my calculator just to see what I get. And sure enough, 36 is the result. So 36 times 3 is 108. And 36 just happens to divide into 72 as well, 2 times, which is what we want there. Perfect. So my greatest common factor between these 2, and it's going to be negative because this term is negative, and remember I want it to be positive. So I'm going to factor a negative 36 out of both of these and bring that out in front. And as I said, 108 divided by 3, or divided by 36, because I thought that was a B for a minute, terrible handwriting. 108 divided by 36 and a negative divided by a negative is going to make a positive 3. And then the x has nothing to cancel with, so it gets brought down. And then negative 72 divided by negative 36 is a positive 2, and then equals 0. So again, these two terms are separated by addition, subtraction signs outside of parentheses. So this is a term and that's a term. They both have a 3x plus 2 in common. So technically, we're going to divide this term by 3x plus 2 and divide this term by 3x plus 2, which means that 3x plus 2 is going to get brought out in front of parentheses. Right, so these are going to cancel. So they cancel, and I'm left with an x squared. And then these are going to cancel, and so we're left with a minus 36. So then one or both of these should have a value of 0 for their product to be 0. So we're going to set the 3x plus 2 equal to 0, and the x squared minus 36 equal to 0. So let's start with the easier one first. So we're going to start with this one first. We're going to subtract the 2 first. So we get 3x is equal to negative 2. Divide both sides by 3. We get negative 2/3. So here is one solution. Remember, our highest degree term is x to the third, so I'm looking for 3 solutions. So this is 1, I need 2 more. This one happens to be the difference of 2 perfect squares. So it is factorable. I'm going to show you 2 different ways that you could solve for x here. The first way is to factor as the difference of 2 squares. So remember, the difference of 2 squares factor pattern is a plus minus pattern. And then you take the square root of each of these terms. So square root of x squared is x. Square root of 36 is 6. And then you would set each of these terms equal to 0 and solve. So here you get x equals negative 6, and here you get x equals positive 6. So there are your other 2 solutions, making a total of 3. The other way that you could have solved this, or you could have instead added your 36 to both sides and isolated that x squared. But the problem with using this method is that you have to remember, when you take the square root of the left side, you have to do plus or minus, because you should always keep in mind, how many solutions do I need? So the square root of x squared is x equals plus or minus the square root of 36 is 6. So this solution is the same as those 2 combined. So it doesn't matter to me which one you do, just make sure that you're accurate at whichever one you choose. All right, so then we're going to move on to number 12. Number 12 is just like either 2, 4, or 6. So I want you to pause a moment and determine which one it's similar to. All right, if you said number 4, you are correct. So I would like you to pause the video and try to solve this by factoring just like we did with number 4, by letting u equal your x squared, and u squared is going to equal your x to the 4th. So go ahead and pause the video, solve it, and see if you can replicate what we did in that example, and then restart the video. Okay, so you should let, and I'm going to erase this one, so we're going to let u equal the variable string of our middle term. So we're letting u equal x squared. So that must mean that if I square u, then I have to square the x squared. So x squared squared, power to power we multiply, must mean that it's x to the 4th. So I'm going to replace x to the 4th with u squared and x squared with just a u. So we are going to factor u squared minus u minus 12 equals 0. So if you read it backwards, what factors of 12 subtract to give you 1? What factors of 12 subtract to give you 1? So 1 and 12 is 11, 2 and 6 is 4, and 3 and 4 is 1. So there's your factors that subtract to give you 1. Our 1 is negative, So the bigger of the two carries that sign, so 4 is negative. The 3 is going to have to be positive to combine with that 4 to make a -1. So u squared is going to become u and u, and you're going to put in the +3 and the -4. Now bear in mind, our highest degree term is 4, so we want 4 solutions total. So we've got u +3, we're going to set that equal to 0, and u -4, we're going to set that equal to 0. So subtract 3, u is equal to -3, and add 4, u is equal to 4. Then you want to replace your u with the value of u, which is x squared. So instead of u, we have x squared for both of these. So we have x squared equals -3, and x squared equals +4. So when we go to solve for x, we're going to take plus or minus the square root of both of these right sides. So we get x is equal to, we cannot take the square root of 3, much less a negative, but remember that that negative is I. So we're going to bring that out in front as plus or minus I, because that's the square root of -1, times the square root of 3. So that is in imaginary. That's actually 2 imaginary roots. Imaginary roots come in pairs. And then over here, we're going to end up with square root of x squared is x, square root of 4, so plus or minus 2. So here we get real roots. So you do have 4 solutions, only 2 of them are real. All right, last problem is going to be number 14, right here. So again, this one does not have 4 terms, so we're not factored by grouping. And it does have x to the 4th and x squared, so it's just like example 4 and example 12, only you have a little bit more complicated trinomial to factor once you replace the x squared and the x to the 4th with their values of u. So if you're comfortable, you can go ahead and pause the video, attempt this on your own, and then restart to see how you do. If you're uncomfortable with that 5 being in front of the x to the 4th, you can follow along with me. All right, so we are going to look at that middle term, and we're going to let u equal x squared, and that means that u squared is going to be x to the 4th. So x to the 4th is going to become u squared, and x squared is going to become u. So we're really factoring 5u squared minus 17u plus 12 equals 0. And then we are going to have to swing multiply here. So we're going to take this 5 and multiply it to the 12. So we get u squared minus 17u plus 5 times 12 is 60 is equal to 0. So we're going to factor this trinomial. You're going to read it backwards. What factors of 60 add to give you 17? So off to the side, we're going to find the factors of 60. 60 is positive, so we're adding them to get to 17. So 1 and 60 is 61. 2 goes in there 30 times, that's 32. 3 divides into 60 20 times, so that's 23. 4 goes into 60 15 times, so that's 19. We're getting a lot closer. And then 5 goes into 60 12 times. That's how we got 60 in the first place. And lo and behold, that is our 17. Your 17 is negative, so the bigger of the two gets that same sign. 5 is also going to have to be negative. So u squared is going to become u, and then minus 5 and minus 12. So then we're going to set u minus 5 equal to 0 and u minus 12 equal to 0. Add 5, you get u equals 5. Add 12, you get u equals 12. Replace your u's with the value of x squared. So we've got x squared here and x squared here. And then equals 5 equals 5. Solve for x, take the square root of both sides, and plus or minus. Take the square root of both sides, plus or minus. So we end up with, remember we're looking for 4 total solutions. X is equal to positive or negative square root of 5. I don't know how I got 12 over there. Hang on. That shouldn't be 5. That should be 12. 12, right? All right, so then square root of x squared is x. So this one's 2 good solutions. They are real, but irrational roots. Irrational roots come in pairs. This one we're going to have plus or minus, and I'm going to prime factor 12 into 2 times 2 times 3. And you're going to pull out a 2 out in front, so you end up with x equaling positive or negative 2 radical 3. So we have another set of real but irrational roots. So these are also real and irrational. So all 4 are real and irrational. And that's it. So go ahead and finish the rest of this page for your homework and let us know if you have any questions. Good luck.